Welcome to the video on the nature of science. This video correlates with the Boundless book, Chapter 1, Section 1, as well as a similar portion of the OpenStax textbook. So, looking at what science does and what it doesn't do, science tends to answer testable questions. Looking at the two images on the left, these come from my husband's blog, paleolab.org, and you can follow that link if you'd like to read the entire article. But an example of a question that science can address is, how do we get fossil shark's teeth that were never found to coexist in the same deposit? That's a question that we can examine the evidence and come up with hypotheses and reasonably answer. What science cannot do is really answer any question that is not testable. So matters of faith or magic or the supernatural, we can't test these things, and so science cannot answer any of these types of questions. So within the spectrum of how science works, science can address questions that are, again, testable. You can design an experiment and run through it and look to disprove your initial hypothesis. And if you never are able to disprove it, it becomes stronger and stronger until finally it is accepted as being the truth. The tests have to be repeatable. Once I have performed an experiment, I need to be able to write down exactly what I did and have other people able to follow in my footsteps. They have to be able to do it for themselves to show that what I said about the experiment was actually valid. So testable and repeatable. Science is also inherently tentative. Whenever new evidence is found, it might change your ideas. It might be a radical change in which we throw out the ideas that we thought were right. We threw out the idea of the geocentric universe. We no longer believe that the Earth is the center of the universe and that the sun, the stars, and all of the planets revolve around the Earth. That was a tentative idea, and it was found to be incorrect. They might be small changes. We might realize, oh, okay, our basic idea was right, but, it works this way instead of that way. So science is inherently tentative. It also searches to make naturalistic explanations that are supported by empirical evidence. So we are explaining with science things that occur in nature and things that can be supported by tests. That's what the empirical evidence means. If we just have to kind of brainstorm ideas and hope that we're right, that's not science. Science is also creative. We tend to think of the arts as being creative and the sciences as being purely logical, but that's really not the case. If you're going to come up with an explanation that fits all of the different pieces, you have to be able to look at the world in a new way that nobody has done before, and that's inherently creative. So science really is a creative process. It has to be internally consistent. You can't have a law or a hypothesis that works for one situation but doesn't work for another. If we're going to say that organisms change through means of natural selection, it can't be only for birds, but not for fish. If it's going to work for one group, it has to work for the other groups, and thus be internally consistent. And it has the goal of explaining and letting us understand the nature of the natural world. So again, things that can be observed, processes that can be experimented upon to form these testable, repeatable, tentative, creatively developed, internally consistent ideas and explanations supported by empirical evidence. And that is really the nature of science. Another aspect of science is that it doesn't look to prove something. We don't say, okay, here is the smoking gun. This is the proof that I was right and you were wrong. What you do instead is you look to disprove your idea. And if you cannot, and after hundreds and after thousands of experiments, and after years or after decades, or perhaps even after centuries, no one is able to disprove the idea, then it's viewed as being true. So you can't actually prove that it is gravity that makes an object fall, but after billions of times that an object has been dropped and it never goes up, it always goes down, we accept that there is indeed a force and that we call this force gravity. But we never proved its existence, we just failed to disprove it. There are two different types of scientific reasoning. One of them is deductive and the other is inductive. And in general, with deductive reasoning, you're given a premise, and from this general idea, specific details are predicted, whereas inductive reasoning is just the opposite. You have a series of details or a set of observations, and those lead you to a general conclusion about perhaps how the world works. And so the next slide is going to look at a series of examples. So pause the video, take a moment to read these four, and try to decide if they are deductive, if you're going from general to specific, or if they are inductive, you're starting out with specific observations or statements and making a general conclusion. So pause the video now and come back when you're ready. Okay, now that you've had time to do this, do notice on the bottom that if you go to your OpenStax book on page 18, there are some additional questions for you to try, and the answers are at the end of the book. But we had for the first one inductive. What that means is we started with specific statements and we're making generalized conclusions. 2 and 3 were just the opposite. We started with generalizations and led to specific inferences or hypotheses, and with the fourth one again back to inductive. And all of this is about science, but there's also pseudoscience out there, and unfortunately what makes it difficult to distinguish the two is that with pseudoscience they make claims that are presented as being scientific, but they haven't followed the appropriate methodology. They lack evidence or appropriate levels of investigation. Perhaps they did one experiment, but it wasn't repeatable. For instance, we've had literally a century of people making claims about miracle solutions for weight loss. And yes, while it might work for, one person, it hasn't been rigorously studied with controlled experiments conducted to make sure that this is universally true. And thus, failing to disprove it, or having disproved it with certain experiments, these cannot be accepted as science. They tend to rely a lot on one person making a claim. I used this weight loss product and I lost weight, therefore it's wonderful. And if you're interested in this, if you follow the link at the bottom, there's a fairly lengthy blog post discussing the differences between pseudoscience and science. So if you go to OpenStax at the end of the chapter, page 34 has 3 questions. Give them a try. Inductive and deductive reasoning is something that is quite important for pretty much any field of study, whether it's a science or not. And it is a part of the exit exam that you take when you are graduating from Patrick Henry Community College. So take a look at these and don't hesitate to contact me if you have any questions.